case, which was case 2, is that we are working with the t-distribution. T-distribution has two main applications. One is that when we are interested to find out, we are in case 2, we are interested to find out mu from the sample, from population, that's the parameter of interest, and sigma 2 is unknown. We don't know the variance of the population. So we would go, we want to be a little more conservative. We work with the t-table. T-table is very similar to the z-table. The only thing is that with the t-distribution, we consider, when we want to read the data from the table, we would need to know that what's the sample size. So it's like the degree of freedom. We need to know the degree of freedom when we are reading there. If you look at the t-distribution, you will see that we have alpha and then we have the n as well, like the sample size as well. So here it says that with the normal, case 1, we would say x bar plus minus 1.96, for example, if it's 95%. Sigma over square root of n. With the t-distribution, which is a little more conservative, and it happens when we don't know the variance or standard deviation of the population, we would say x bar plus minus t times s over square root of n. So t factor is the tabulated value of the t-distribution with n minus 1 degree of freedom, as I told you, and the significance level of the alpha. The confidence level is going to be 1 minus alpha. Like, for example, if you have the confidence level of 95%, alpha is going to be 5%, for example. So I said that we have two applications for this t-distribution. One is that when we are working with case 2, so we would need to, when we want to find out the confidence interval of that, so we're going to find out t value. Another application is that when we are want to compare like a multiple samples. So we're going to work on that later. It's on the like chapters after, like 4 or 5. It should be 5, I think, here in this course. But you will see that we work with the t-distribution over there as well. So you can see here, for example, this is for the normal distribution of the 0 and 1, and then this is going to be the t-distribution. So it's very, the t-distribution has a very similar shape compared to the, like it has a similar bell-shaped curve, right? But for different sample size, we are going to have a different shape for the for that specific t-distribution of the sample. So what this slide says is that this one, if it's based on the z-distribution, if you have like 10 sample, or if you have like 20 sample, this distribution is going to be like this, or maybe a little different. But for this t-distribution, because the t-distribution is based on the different size of the sample, so we have degree of freedom in it. So if you have 10 sample or 20 sample, this t-distribution is going to change. So that's the, for example, n is equal to 25. The degree of freedom is going to be 24, right? It's just an example. And then from the table of the, for the, you can work on this example. Think about the confidence interval of 95%. N is equal to 25. Read the t value. See what's going to be the t value for it. So let's work on an example that I said. We want to, I wrote down here, I paused the video and wrote it down, just to save time. So it's like that, we are working on case 2. The parameter of interest is mu, sigma 2 is unknown when we say case 2. So we need to work with the t table, not z table. And what do we have is that n is 25. We have a 95% confidence interval, and also we are working with the two-sided test. Means that if I have something like this, I'm considering both two-sided. It's not one-sided. So what I'm going to do is that we are working with the, because it's case 2, it's going to tell me that I would need to work with the t-table or t-distribution. N is equal to 25, so the degree of freedom. Degree of freedom, you can show it by K. You can show it in the Montgomery book, they show it by nu. I always use DOF or DF because when you look at it, it's like degree of freedom. So it's easier to remember, in fact, for me. So the degree of freedom here is going to be 24. We said n minus 1 in these cases. And then 95% confidence interval. So alpha is going to be 5%, and the half of the alpha is going to be 0.025. Now we need to go to the t table and read the t value. So we are interested, look how I write it down. We are interested to find out t at half of the alpha and n minus 1. So I'm interested to find out the value for it. So here it's going to be t at half of the alpha 0.025, and then n minus 1 is 24. So let's go to the table. Chair. Okay. So I posted the t table on Learn as well. So you can see that I'm trying to find it out first by myself and then go through the steps with you. Okay, awesome. So it's like that. Look at here. The first column, this is the t table. So in z table, the probability was here, and then we had the like z values here. In t table, because we have three different data, like three different sets of the variables, so we need to consider alpha, half of the alpha, or if it's one-sided alpha, and then we need to consider the degree of freedom, and we will find out the t value for it. So we would have three. Because of that, the first column and first row, they have the different, they are representing different values. So the first column is written new, and on the bottom of the table, it's written that, it's okay if it's not that much clear, you will have your own t table while you are working with that. So it's written degree of freedom. So this one represents degree of freedom. One of the mistakes that I've seen that we do over time is that degree of freedom, when I give you degree of, you want to put a degree of freedom, make sure that you consider the sample size. And if it's like this, it's going to be n minus 1. We have cases that the degree of freedom is going to be n minus 2. We are going to go over that later. And then, so it's going to be, this first column is the degree of freedom. So here, degree of freedom is 24, right? So we have 24. And then the t, the first column represent alpha or half of the alpha. So whatever probability, like chance of the, for the alpha that we are looking for. If it was one-sided, I would consider these ones alpha. If it's two-sided, I would consider the value of the half of the alpha. For example, here is 0.025, right? So when it's 0.025, I'm going to go and look at all of this, and you can see here, it's 0.025 that I consider. So 0.025, and then I'm going to come down, and I will look at the 24. So this is going to be the value for it. So representing for the t at the 24 as degree of freedom, and 0.025 as the half of the alpha. Another mistake that I see that we do over time is that, be careful, this is 0.025. We have 0.0025 as well, like a little further. So I've seen that the students, unfortunately, they read this value, just, it's a typo. I'm just telling you that the mistakes I've seen over years. So you will go and then we will read it. It's going to be 2.064. When we read it, it's here. So the t value is going to be 2.064. It means that if I want to write down the mu for it, mu is going to be x bar plus minus t value times s over square root of n. I'm going to write down here first like this, x bar, the confidence interval, plus minus t value, which is the 2.064, times s over square root of n. So that's my confidence interval, like the real interval. The other way that you will see that they're writing down when you are working with this is that both of them are correct, both of them are acceptable. But maybe you will see that we would write down like this. Mu is between two values, the interval, and then here is 2.6064 s over square root of n. We call this one a standard error, by the way. A standard error of x bar. It's the, so if it was case one, it would be sigma over square root of n. We would call that one a standard error of x bar as well. And here would be minus 2.064. Like here, oh, I forgot the x bar. So let me just fix it. It's X bar plus this one, and here would be X bar minus 2.064 S over square root of n. So that's going to be two bounds of lower bound and upper bound of our confidence interval. So that's the that's just an example for the t-distribution, to review the t-distribution. Let's go back to the notes. We just have one slide left, I believe. Okay, yeah. So we wrapped the first part of the review. So it's now you can go and look at the tutorial. The tutorial name is that, it's tutorial 1, but it's like that. It's chapter 1, the name of the file. Chapter 1, example 1, and chapter 1, example 2. So there are 2 examples, and it's gonna, it's just, you can practice on it. I would recommend that before going to the next set of videos. And because I'm going to talk about hypothesis testing, and hypothesis testing is very similar to the confidence interval, but it's good that you practice on some examples before going there. And then here it says that hypothesis testing, HT, and confidence intervals, they have the same math background. They're complementary, but we are looking at it from a slightly different angle. The starting point is different, but it's very good that if you first master, like, we remember everything about the confidence intervals. So when we are talking about the confidence interval, I just talked about the case 1 and case 2. We have it for case 3 and case 4 as well. And make sure that you're going to look at that one on the second year stats, like basic stats, in fact, material. So that's all for now. The next one is the like the hypothesis testing. Still, we are going to be in the chapter 1, but it's the second part, like second huge part of the chapter 1.